Welcome to the deep dive. We're about to jump into a stack of material you've shared with us, focusing today on excerpts from Carl Sagan's uh, truly monumental work, Cosmos.
Yeah, and this deep dive, it's not just about listing facts, is it? It's really about getting perspective. We're using Sagan's incredible lens to explore our place in the universe, trace the vast history of life and thought,
hmm
and sort of grapple with some really profound challenges and possibilities for humanity.
And what a mind to guide us. Sagan was, well, more than just a scientist. He was such a communicator, director of the Laboratory for Planetary Studies at Cornell,
Right.
a key player in those iconic planetary missions. Mariner, Viking, Voyager, got NASA medals for it.
Yeah, he was right in the thick of it.
Chaired divisions in major scientific societies, edited Icarus for years,
Yeah.
wrote a stack of influential books, like The Cosmic Connection, The Dragons of Eden,
Mm-hmm.
even won a Pulitzer Prize.
Wow.
It's pretty clear why he dedicated Cosmos to Anne Druyan, his partner in, well, bringing this whole vision to the world.
He just had this unique ability, didn't he? Making the really complex stuff accessible, connecting cutting-edge science right back to the human experience.
Exactly. So our mission for this deep dive is basically to pull out the absolute most important nuggets, find those aha moments that make the universe kind of click,
Mm-hmm.
and help you gain a deeper understanding from this rich material without feeling like you're trying to, swallow the whole cosmos at once.
Okay, let's start our journey then, as Sagan often invites us to, on the shores of the cosmic ocean.
That phrase itself, and even the dedication in the vastness of space and the immensity of time, it is my joy to share a planet and an epoch with Annie. It just immediately humbles you with the scale, doesn't it?
It really does. It instantly places our sort of fleeting existence against this backdrop of truly immense scales. And the source material, it takes us right back to the ultimate beginning, the Big Bang.
Right. Somewhere between 10 and 20 billion years ago, this singular event that sparked our entire universe.
Yeah.
The sources mention it might have started from something incredibly dense, maybe?
Mm.
Maybe even just a mathematical point?
The why is still a huge mystery, of course, but that it happened is, well, foundational to our current cosmological understanding. The early universe was incredibly hot and dense, primarily just this sea of radiation, hydrogen, and helium.
And Sagan describes how tiny, almost infinitesimal variations in that early gas, those little non-uniformities, started to attract material gravitationally.
Yes, exactly, causing them to grow into these vast clouds of gas that would eventually collapse and flatten out to form galaxies. The sources talk about the different shapes.
Yeah, the spirals.
Right, spiral galaxies spinning and flattened because of conserved angular momentum, and then elliptical ones which maybe had less initial spin or weaker gravity, something like that.
And they crash into each other. Galaxies aren't static things. They're fluid structures that can interact, creating these temporary splash features like ring galaxies.
That's a great way to put it. It's like thinking of a human not just as a fixed collection of cells, but this dynamic system where the whole is way more than the sum of its parts.
Yeah.
A perfect analogy. And the scale of these structures is just, well, mind-boggling. Potentially 100 billion galaxies in the observable universe, clustered together in groups from just dozens to thousands.
Wow.
But from that vastness, the source material brings us right back home, focusing on the early Earth.
The picture painted is incredibly vivid. Oceans filled with this organic soup. You just imagine lightning crackling and ultraviolet light streaming down, breaking apart the simple molecules in that hydrogen-rich atmosphere.
Oh, and these fragments would then recombine, forming more complex molecules, the precursors to life. The critical breakthrough, according to the source, wasn't just getting complex molecules, but finding one that could make copies of itself.
A molecule that could use the other stuff floating around in the soup as building blocks to reproduce the earliest ancestor of DNA.
Yes, the double helix, that twisted ladder structure with the 4 nucleotide letters making up the genetic code. The sequence of those letters, that's the instruction manual.
And the differences in those instructions are what make everything from a bacterium to a blue whale to, well, us unique. Evolution at this molecular level was driven by reproduction, competition for resources, and mutation, just random changes in those letters.
Most mutations are, dead ends. They create biological machinery that just doesn't work. But occasionally, just by chance, one is beneficial, giving that molecule, or later on that organism, a slight edge. That's the engine of evolution.
Right.
And the source describes this early period, maybe 4 billion years ago, as a kind of molecular Garden of Eden, because crucially, there are no predators yet.
Nothing around to eat the struggling first replicators.
Exactly, so they had a chance. And over time, these reproducing molecules got more efficient. Eventually, they formed partnerships, collections of molecules with specialized jobs coming together to form the first cell, a molecular collective.
Like a tiny cooperative.
Yeah. The source even speculates that parts of our cells today, like chloroplasts in plants or mitochondria in us, might have once been independent, free-living things that got incorporated.
That's wild. This cellular collective then evolved further. By about 3 billion years ago, single-celled plants started sticking together after dividing.
Uh-huh. Leading towards multicellular life.
And that pathway eventually leads to us, each of us, this incredibly complex commune of 100 trillion cells. Then, around 2 billion years ago, something really revolutionary happened, according to the source: the invention of sex.
That seems incredibly late. 3 billion years into life's history before sex appears?
It does seem late, doesn't it? But think about it this way. Before sex, the only way to get new variations was through those slow, random, letter-by-letter mutations in the DNA code. Sex allowed organisms to swap entire chunks of code, rapidly recombining traits. Oh, okay, so it massively speeds up the evolutionary process.
Precisely. Organisms that developed sex suddenly had this huge advantage. They could adapt much faster to changing conditions. The source says organisms are actually selected to engage in sex because those relying only on slow mutation eventually just get outcompeted or can't keep up when the environment changes and they become extinct.
And speaking of changing environments, the sources highlight a massive planetary crisis caused by life itself: the oxygen crisis. Plants, doing their photosynthesis thing, started pumping out oxygen.
And the crucial insight here, which is easy to forget, is that oxygen is fundamentally a poison. For unprotected organic matter, it's highly reactive, it's destructive. This was a huge challenge for the early anaerobic life forms. Many just died out.
Makes sense why some ancient forms, like botulism bacteria, can only survive in oxygen-free places today. They never adapted.
Exactly. But others did adapt. They evolved ways not just to tolerate oxygen, but actually to use it, which unlocked way more energy from food. And the source makes another incredible point. It's not just oxygen, but nitrogen too, the other main gas in our air, is biologically sustained.
So, the stunning takeaway is that something like 99% of the air around us is of biological origin.
The sky is quite literally made by life. That's a profound shift in perspective, isn't it? The atmosphere isn't just this passive envelope, it's a dynamic system, created and maintained by the organisms living right here on the planet.
Thinking about that huge stretch of time, billions of years dominated by microscopic blue-green algae, it really underscores how exceptional complex life feels.
It does. The source points out that life arising relatively quickly after Earth form might suggest that, the initial spark, the basic chemistry, is maybe an almost inevitable process on an Earth-like planet.
But that incredibly long wait, 3 billion years, before the Cambrian explosion suggests that evolving large, complex organisms with specialized organs is much harder.
Which leads to that fascinating possibility. Maybe microbial life is common out there in the cosmos, but planets with big beasts and vegetables like us might be exceedingly rare.
After the Cambrian explosion, around 600 million years ago, life in the oceans just exploded with diversity, finally breaking the algae's long, long reign.
The sources mention these incredible creatures from that era, like trilobites, around 500 million years ago, described as beautifully constructed, sort of like giant insects. Some even hunted in packs, apparently using crystals in their eyes to see polarized light.
Crystals in their eyes, that is amazing. But they're gone now, right? Extinct for 200 million years.
And that's a key point the source really emphasizes. Species appear, they thrive for a while, and then they flicker out. It's the norm. If you look at the ancient rocks, there's just no hint of animals like us. Our species is a very, very recent arrival on this timeline.
The pace of evolution seems to pick up dramatically after the Cambrian, though.
Oh, absolutely. The fossil record shows a comparatively breathtaking speed after that initial slow burn. You get fish, vertebrates, plants moving onto land, insects, winged insects, amphibians, trees, reptiles, dinosaurs, mammals, birds, flowers, leading right up to the dinosaur extinction.
Which then paved the way for the rise of mammals, including cetaceans and primates. And then, the sources note, creatures vaguely resembling humans appeared less than 10 million years ago, with that really spectacular increase in brain size happening relatively recently.
The first true humans, anatomically speaking, only a few million years ago, we are incredibly recent guests on this planet. The sources also contrast the simplest forms of life with the complex ones.
like viroids, these tiny strands of nucleic acid, just parasites needing a host cell to do anything. Viruses are a bit more complex, with a protein coat.
Right. And the smallest truly free-living organisms, PPLO they're called, are still relatively simple compared to us, but far more complex than viroids because they have to carry all their own machinery for life. The source notes that the early Earth was probably more favorable for simple, non-parasitic organisms to get started.
And while scientists are doing experiments today, trying to maybe recreate these early life forms from scratch in the lab, as the source says, nature has had a 4 billion-year head start. It's a tough act to follow.
The basic chemistry for life seems pretty common throughout the cosmos, you know? The molecules of life, amino acids and stuff, they're found in nebulae, comets, meteorites. But while the chemistry might be similar, the source stresses that we really shouldn't expect extraterrestrial life to look like familiar Earth organisms.
That makes sense. Given the incredible diversity just here on Earth, all built on the same basic molecular foundation, it seems highly unlikely that random evolutionary paths on other planets would end up producing anything remotely like Earth creatures. Maybe some convergent evolution for things like sensing light or motion, but otherwise, totally alien.
Sagan himself was apparently quite skeptical of many science fiction portrayals, finding they often relied way too much on forms we already know. Any given organism, including us, is the result of a very specific, often highly unlikely, series of historical accidents and adaptations.
Okay, moving from the origins of life right here, the source material swings us back out to the cosmos, specifically focusing on objects that have long captured human attention and often human fear, like comets.
Oh yeah, comets have this deep, deep history tied to superstition. The sources give us examples. Babylonians saw them as beards, Greeks saw flowing hair, Arabs saw flaming swords.
Right.
Ptolemy linked them to wars and, general disturbances. Medieval people apparently saw them as flying crucifixes.
And that utterly brilliant, if completely wrong, idea from Andreas Salichtius in 1578 that a comet was made of the thick smoke of human sins.
Ah. Huh? Which others logically countered would mean the sky should be constantly full of them. But seriously, comets were genuinely terrifying. Because they were unpredictable, they appeared to defy the orderly heavens, and historically, they often did seem to coincide with major events.
Halley's Comet just keeps popping up. Recorded by the Chinese way back in 1057 BC, possibly that sword over Jerusalem in 66 AD mentioned by Josephus, certainly in the Bayeux Tapestry in 1066.
Right, linked to the Norman invasion.
Giotto even painted it into a nativity scene in 1301.
And the panic in 1466 related to the Great Comet and the Turkish capture of Constantinople. This all just highlights how, when you lack a scientific understanding, you project your fears and narratives onto these cosmic events.
But then science started to cut through the superstition. Kepler saw them as darting objects, their tails always pushed away from the sun. Newton, using his new laws, figured out they were celestial bodies, beyond the moon but closer than Saturn, shining by reflected light and moving in these highly eccentric elliptical orbits. He called them a sword of planets.
And Edmund Halley, applying Newton's methods, made history by calculating the period of the comet we now call Halley's and correctly predicting its return in 1758. That was a huge step, demystifying them.
Scientists also started analyzing what they were made of. Huggins found organic matter in comet spectra, things like cyanogen.
Which, interestingly, in 1910 led to a bit of a panic when Earth was projected to pass through Halley's tail. The sources amusingly mention headlines about anti-comet pills and gas masks being sold.
And that great San Francisco Chronicle headline, "Comet Comes and Husband Reforms." People completely overlooked how incredibly thin and diffuse a comet tail actually is.
There's that wonderful anecdote from Sagan himself as a grad student, getting a call from a guy who'd clearly had a bit too much to drink, asking about Comet Aaron Roland. The guy couldn't see it when he looked directly at it.
A reverted vision.
Yeah. And Sagan's description, a snowball 1 mile across, was clearly not the fiery apparition this caller expected from a real Strohminer.
That story perfectly captures that transition, doesn't it? From this fear-driven mystical view to the scientific reality, which can seem almost underwhelming if you're expecting a giant celestial sword.
Exactly. And speaking of reality, cometary orbits are dramatically different from planetary ones.
Yeah, much more stretched out, elliptical. The source explains this is probably because planetary orbits are the survivors of collisional natural selection in the early solar system. Circular orbits were just more stable, less likely to crash into things or get flung out.
And way out in the distant reaches of the solar system is the Oort cloud, this vast reservoir of maybe 1 trillion cometary nuclei, mostly stable until a passing star or some other disturbance sends one plunging inward on that highly elliptical path toward the sun.
And these objects, comets and asteroids, they collide with planets and moons. The source mentions the Tunguska event in Siberia back in 1908, likely a small fragment, maybe a stony asteroid, estimated as roughly a 1,000-year event on Earth's timescale.
But a Halley-sized impact, a 20-kilometer object, that's a much rarer, maybe billion-year event, but with potentially catastrophic consequences.
And the evidence of these impacts is just all over the solar system. The moon is absolutely plastered with impact craters, perfectly preserved because there's no atmosphere or water to erode them away. They're a record of a much more violent past.
You see them on Mercury, Venus, Mars, and the moons of the outer planets, too. The sources draw a really interesting contrast between the moon and Earth.
Yeah, the impact rate should be pretty similar.
Right, but on Earth, craters are constantly being erased by geological activity and erosion water, wind, plate tectonics, mountain building. Over millions and billions of years, they just vanish.
So while a kilometer-sized crater might hit the moon every 100,000 years or so, on Earth, it's maybe more like one every 10,000 years. That fits with things like Meteor Crater in Arizona, which is about a kilometer across and only 30,000 years old.
It really highlights how geologically active and dynamic Earth is compared to the moon. There's even that fascinating historical account from 1178 of 5 British monks reporting seeing a massive impact flash on the moon. Right from Earth, a statistically unlikely thing to witness, perhaps, but not impossible.
Wow. And the asteroid belt between Mars and Jupiter is described as a kind of grinding mill, constantly producing smaller pieces, some of which eventually find their way to Earth as meteorites, little fragments of distant worlds ending up in our museums.
The sources then pivot a bit, talking about Mars and why it's been such a focus of speculation about life, particularly intelligent life. At first glance, it seemed the most Earth-like of our neighbors.
Which made it a tempting screen to project our hopes and fears onto, leading to ideas like Percival Lowell's famous canals. The source uses this neat perspective of an alien visitor approaching Earth to illustrate how a technical civilization might reveal itself from orbit.
Yeah, that's clever. At low resolution, Earth just looks mostly barren land or cloud-covered ocean. But you zoom in to maybe 100-meter resolution, and suddenly geometric patterns appear. Roads, farmland, cities revealing our twin human passions for Euclidean geometry and territoriality.
Within a 10-meter resolution, the scale of how much humans have modified the landscape becomes undeniable. And at night, the lights give us away completely. Cities blazing, oil flares, fishing fleets out in the oceans. Finally, at meter resolution, you'd see individual organisms, vehicles.
So the source suggests technical civilizations that heavily modify their planetary surface, like those imagined Martians building canals, might actually be relatively easy to spot visually from space. The Viking missions were the first really serious attempt to look for life elsewhere, specifically landing on Mars.
They sent back incredible data, truly groundbreaking. But Sagan expresses a kind of scientific impatience. With the immobility of the landers, you could only explore the tiny patch right where you landed.
Which is exactly why missions with roving vehicles like the ones we have now are so crucial. They can actually traverse the landscape, conduct experiments in different geological contexts, look for evidence of past or present life, maybe hidden underground where it's shielded from the harsh surface conditions.
And the Martian environment is incredibly harsh. Frigid temperatures, a really thin carbon dioxide atmosphere, very low pressure, meaning liquid water just boils away on the surface, almost no oxygen or ozone layer.
And that lack of ozone is absolutely key. Germicidal ultraviolet radiation from the sun just hammers the surface unimpeded. Could anything survive that? The sources mention experiments Sagan and his colleagues did back then, simulating the Martian environment in the lab, and finding that surprisingly, some terrestrial microbes could actually thrive under those simulated conditions if they had a little water.
Which raises really serious concerns about planetary protection, not just about us contaminating Mars with Earth life, but also the potential danger of back contamination if we ever bring unsterilized samples back from Mars. What if Martian life exists and it's something our biology isn't prepared for?
Exactly. The search for life, as exciting as it is deeply intertwined with these profound questions of responsibility and caution.
Okay, so from the cosmic and planetary scale, the source material takes this fascinating turn, exploring humanity's own journey of understanding, weaving together history, science, and also the dark side of knowledge suppression.
Yeah, this section highlights some of those early Greek thinkers who began to investigate the world using reason and observation, moving away from purely mythic explanations. Empedocles, around 450 BC, doing what sounds like a simple but really profound experiment with a clepsydra, a water thief, just to demonstrate that air, this invisible stuff, actually exists.
Showing the invisible using observation.
Amazing.
He also apparently had ideas anticipating natural selection, suggesting that organisms unable to reproduce properly would just fail to survive and pass on their traits.
Then there's Democritus of Abdera, who came up with the word atom, meaning unable to be cut. He had this radical idea that everything was made of atoms moving in a void, a purely materialistic view, seeing thinking and feeling as just properties of complex arrangements of matter.
He even applied this idea of infinite divisibility to geometry, like cutting a cone, which touches on the theory of limits, a precursor to calculus. And he thought there were many spontaneous worlds out there, some inhabited.
It's described as truly tragic that almost all of Democritus's 73 books were destroyed. We only know his ideas from fragments and accounts written by others, often people who were hostile to his ideas.
Just a massive loss to human knowledge. Contrast this with Pythagoras from the 6th century BC. He discovered the Pythagorean theorem, of course, and really developed mathematical deduction, which is fundamental to science. He also first used the word cosmos to mean a well-ordered universe.
But unlike the Ionians who valued observation and experiment, Pythagoras and his followers were, well, mathematicians, but also mystics. They believed the universe's laws could be deduced through pure thought alone, that mathematics held the key to everything.
And their fascination with the 5 regular solids, linking them mystically to the elements, actually led them into a crisis when they discovered the irrationality of the square root of 2 using their own theorem. It shattered their worldview that the universe was based on perfect whole numbers and their ratios.
And instead of embracing this inconvenient new truth, what did they do? They suppressed it. They reportedly wanted to keep this discovery secret within their group. The source contrasts this attitude with the spirit of open inquiry, quoting Cicero saying that in discussion, the force of argument, not just authority, should prevail.
This reliance on authority, the master said so, over evidence, and their sort of distaste for experiment, their embrace of mysticism, and their acceptance of slavery are presented in the source as forces that actually held back scientific progress, despite their crucial contributions in showing the cosmos as knowable and mathematical.
Plato and Aristotle, though advancing philosophy in many ways, also contributed to the shift away from Ionian experimentalism, justifying social hierarchies, separating mind and body, earth and heavens in ways that dominated Western thought for centuries. Plato even advocated for burning Democritus's books.
This suppression, this long mystical sleep for scientific inquiry, as Sagan puts it, is framed as a really significant setback for humanity. The Ionian spirit of empirical observation had to be painstakingly rediscovered centuries later, inspiring figures like Leonardo, Columbus, and Copernicus.
The Alexandrian Library is highlighted as this incredible beacon of enlightenment during that later period. Aristarchus, working there about 3 centuries after Pythagoras, was apparently the first to propose a sun-centered solar system, though his writings on this were tragically lost.
And the end of the library is just described so tragically, culminating in the horrific death of Hypatia in Alexandria in 415 AD.
Yeah, described as the last great scientist of the library, a brilliant mathematician, astronomer, physicist, head of the Neoplatonic school there, an extraordinary woman in an age where women were largely treated as property. She became a symbol of learning and science, which the increasingly powerful early Christian church leadership identified with paganism and heresy.
A fanatical mob, apparently spurred on by the patriarch Cyril, dragged her from her chariot into a church, flayed her to death with abalone shells or pottery shards, burned her remains, obliterated her works,
It's just gruesome.
and had her name essentially forgotten, while Cyril was later made a saint.
The source describes this event and the broader destruction of the library's knowledge as civilization undergoing self-inflicted brain surgery, deliberately destroying its own memories, its own hard-won understanding. Only 7 of Sophocles' 123 plays survived the library's destruction. Imagine losing almost all of Shakespeare's work.
It's a truly chilling reminder of how fragile knowledge can be and how easily it can be suppressed by dogma, by fear, by authority. The sources note that while we've rediscovered that Ionian approach, those ancient contradictions, superstition, unquestioning authority, ethical blind spots, they still remain with us today.
Which brings us more towards the modern era and a reevaluation of our place in the cosmos, a journey really accelerated by later scientific discoveries.
Like Copernicus's view that Earth is just another planet orbiting the sun. The source mentions Christian Huygens, noting how ordinary Dutch people back then accepted this idea pretty readily, contrasting them with those who were, in his words, slow-witted or under superstitions imposed by merely human authority.
That shifted perspective immediately implied Earth wasn't special, wasn't the center of everything. It opened up the logical possibility of life on other worlds, which directly challenged the prevailing medieval Christian worldview. Giordano Bruno took it even further, suggesting infinite worlds around infinite other suns.
A radical idea that unfortunately got him burned at the stake.
Ouch indeed. The scale of our own galactic home also shifted dramatically. Before about 1915, we generally thought the sun was near the center of the Milky Way galaxy. Then, Harlow Shapley showed we're actually way out in the galactic suburbs, maybe 30,000 light-years from the core.
And then Edwin Hubble, in 1924, delivered the knockout blow to our cosmic centrality by confirming that the Andromeda Nebula, M31, was another entire galaxy, millions of light-years away. That confirmed the island universe's concept. We learned there are likely 100 billion galaxies out there.
Sagan pulls all this together into that incredibly powerful, humbling perspective. We find ourselves on an insignificant planet of a humdrum star, lost between two spiral arms in the outskirts of a galaxy which is a member of a sparse cluster, tucked away in some forgotten corner of a universe in which there are far more galaxies than people.
It's a perspective that, while maybe initially jarring or deflating, is framed by the source not as diminishing us, but as a courageous continuation of our search for genuine understanding, a necessary step away from a self-centered view to truly grasp the reality of the cosmos.
And the source adds that hopeful counterpoint. If we long for our planet to be significant, we can make it so by the courage of our questions and by the depth of our answers. This ties directly into the search for extraterrestrial intelligence SETI.
Right. The Drake equation is mentioned as a way to sort of organize our thinking about the number of technological civilizations that might be out there in the galaxy. And the source highlights that the biggest unknown factor in that equation isn't really astronomical or biological.
No, it's us, basically. It's economics and politics and what on Earth we call human nature, the factor representing the fraction of civilizations that manage to survive their own technological adolescence without destroying themselves.
Yeah. Can a civilization develop things like nuclear weapons or global environmental impact without wiping itself out? If even a tiny percentage make it through, say 1%, there could still be millions of civilizations out there in our galaxy alone.
So, receiving a message, any credible message from an extraterrestrial civilization would be this profoundly hopeful sign. It would be concrete proof that long-term survival with advanced technology is possible. Even before decoding it, the very act of reception tells us someone out there made it.
The nearest civilization might be, say, 200 light-years away, which means messages take centuries to travel each way. The source suggests that because we are likely technologically much younger than any civilization we might detect, it makes more sense for us to listen carefully rather than just transmitting blindly, at least for now.
SETI efforts are still really in their early days, but the source notes they're relatively inexpensive compared to other large-scale scientific or military endeavors, maybe the cost of a single modern naval destroyer for a decade of dedicated listening.
The source also prompts us to think about what contact, even just receiving a radio signal, might actually mean by looking at our own history of intercultural encounters here on Earth. Direct physical contact hasn't often gone well for the less technologically advanced party, has it?
That's putting it mildly. But a radio signal is different. It's described as light as a kiss, not an invasion fleet. Still, historical encounters can offer cautionary tales or maybe some hopeful possibilities.
Two specific prototypes from human history are presented in the source material. First, the meeting between the French explorer La Perouse and the Tlingit people in Lituya Bay, Alaska in 1786.
The Tlingit oral history, recorded much later from a chief named Cowie, is just fascinating. Seeing the ships initially as great black birds, thinking they might be the raven god from their mythology, hiding in fear, using skunk cabbage leaves as crude telescopes to peek at the crew, who they saw as black messengers or crows.
An old warrior eventually tested the raven by shooting an arrow at it, realizing it was actually a giant canoe made by men. It was a tale of initial misunderstanding, some minor conflict over stolen resources, but ultimately a relatively low-impact encounter. La Perouse, despite some personal disdain for the Tlingit, followed his government's orders to be peaceful.
A really stark contrast to the other prototype offered, Cortez and the Aztecs in the early 16th century. The Aztecs had this incredibly advanced civilization, stunning architecture in Tenochtitlan, sophisticated record-keeping, beautiful art, accurate astronomy. Durer, the artist, saw some of their books and compared them favorably to Egyptian artifacts.
Cortés himself described their capital city as beautiful and the people as orderly and civilized. Yet, within just 2 years, he and his men, with their technological advantages and alliances, utterly destroyed the Aztec civilization.
That's presented as a truly ghastly prototype, a technically more advanced society, completely isolating a culturally rich but less technologically powerful one. It's a chilling historical parallel to keep in mind when we think about potential future ET contact scenarios.
And the source connects these potentials for cooperation, misunderstanding, violence, and destruction right back to our own nature, using Paul MacLean's model of the triune brain to understand our complex motivations.
Right, you have the brainstem, the oldest part, handling basic life functions, breathing, heartbeat. Then layered on top is the R complex, the reptilian brain, evolved hundreds of millions of years ago. The source, according to this model, of aggression, territoriality, ritualistic behavior, establishing social hierarchies.
Then comes the limbic system, the mammalian brain, which evolved later, handling emotions, moods, parental care, especially nurturing behavior towards the young.
And finally, the cerebral cortex, the newest and by far the largest part in humans, unique in its complexity, the seat of consciousness, intuition, critical analysis, where we read, write, do mathematics, compose music, plan for the future, and embark on cosmic voyages of the mind.
The cortex, with its 100 billion neurons, about as many as stars in the Milky Way and maybe 100 trillion connections, is described as our liberation.
Exactly. It allows us to be more than just slaves to the dictates of our ancient, sometimes counterproductive, R complex. We aren't just trapped in purely reptilian or baboon-like behavioral patterns. We can reflect, we can change ourselves. We're largely responsible for what goes into our brains, what we choose to learn and care about.
But brain evolution, like the growth of a city, is messy. The old parts, the R complex and limbic system, remain because they still handle fundamental functions. But their impulses can sometimes conflict dramatically with the needs of a complex, interconnected, global technological society.
And that takes us directly to the ultimate, terrifying demonstration of that conflict. The double-edged sword of our own technology, exemplified most starkly by nuclear weapons.
The source paints a truly terrifying picture. A single modern thermonuclear bomb can release more energy than all the bombs used in World War II combined. By the late 20th century, the superpowers had stockpiled tens of thousands of these warheads, enough for, as Sagan put it, a World War II every second, for many hours.
The immediate effects are just horrific. The blast wave, the intense heat causing firestorms, the prompt radiation. The source includes this visceral account from a Hiroshima schoolgirl survivor,
Ah, that's devastating.
describing the darkness like the bottom of hell, seeing people burned beyond recognition, students desperately trying to escape into a water cistern, the survivors barely appearing human anymore. It's gut-wrenching.
And the long-term effects are just as frightening. Radioactive fallout drifting for miles, like the ash that fell like snow on the Rongelap Atoll after the Bikini test, causing severe health problems years later. A full nuclear exchange, maybe equivalent to 1 million Hiroshima bombs, could kill the current global population many times over.
And survivors would face a drastically altered world. Ozone depletion caused by nitrogen oxides produced in the fireballs would lead to years of increased ultraviolet radiation hitting the surface. This would cause widespread skin cancer, but maybe even more catastrophically, it could kill off vital crops and microorganisms at the very base of the global food web. The potential for ecological collapse is immense.
It's presented as the ultimate test, isn't it? Whether our ancient brain wiring, that R complex with its territoriality and aggression, can cope with the godlike power our more recently evolved cortex has unleashed. But despite these absolutely existential dangers, the source also points to reasons for hope.
Yes, mentioning sweeping global changes that seem to be moving, however slowly, toward survival. Things like the near elimination of abject chattel slavery worldwide, a stirring planet-wide revolution. women gaining equality in many societies, major wars sometimes being prevented or stopped, partly because of widespread citizens' revulsion against them, the fading appeal of raw nationalism and jingoism, children on average being treated better globally, which seems correlated with rising living standards.
These are fundamental societal shifts, suggesting a growing recognition, perhaps, that we are one species and we need to move in directions necessary for our collective survival on this small planet.
The source also includes that incredibly provocative thesis from the psychologist James Prescott, highlighting a strong statistical correlation, something like 125,000 to 1, against it being chance between physical child abuse and severe sexual repression in childhood and the later development of violence and abuse in adults.
If that correlation holds true, the source argues, then in our current age of nuclear weapons and effective contraceptives, these acts against children aren't just personal tragedies. They become potential crimes against the future of humanity itself. And the suggested personal action. Simply hug infants tenderly. It becomes a contribution to survival.
Finally, science itself is presented as both a crucial tool and a profound source of wonder. Theophrastus is quoted, "Superstition is cowardice in the face of the divine." The universe revealed by science, atoms forged in stars, suns being born and dying, life sparked from chemistry, galaxies forming and colliding, quasars, quarks, black holes. The sheer possibility of extraterrestrial civilizations is far more awe-inspiring and intellectually satisfying than superstition or pseudoscience, which are described as just pallid by comparison.
Science is human invention, obviously. It evolves because fundamentally it works. It gives us power, understanding. It's a tool. And like any powerful tool, it's not perfect and it can definitely be misused.
But its core principles are what make it so powerful and, crucially, self-correcting. Rule number 1. There are no sacred truths. All assumptions must be critically examined. Arguments from authority are worthless. Rule number 2. Whatever is inconsistent with the facts, however deeply held, must be discarded or revised. It's the best method we have for understanding the cosmos and hopefully navigating our complex future.
So this deep dive, really guided by Sagan's Cosmos, has taken us on an absolutely extraordinary journey, hasn't it? From the birth of the universe and life itself, through the history of our solar system, the rise and sometimes fall of human knowledge, right up to the critical juncture humanity faces today.
It really shows us a universe of unbelievable scale and incredibly deep history, where life is revealed as both incredibly fragile and somehow remarkably resilient. It highlights how human discovery has often been tragically hindered by suppression, by dogma, by fear of the new.
And it brings us face to face with those profound questions about our actual place. We're definitely not center stage. We're on a small planet in a pretty ordinary part of just one galaxy among billions and billions. Understanding that perspective feels vital.
We've looked at those historical encounters as potential prototypes, haven't we? From the relatively low-impact meeting between La Perouse and the Tlingit to the utterly devastating destruction of the Aztec civilization by Cortés. Those stories offer really sobering lessons about the potential outcomes when different cultures, potentially with different technological levels, meet.
And we've reflected on our own nature, the complex architecture of the human brain, where those ancient impulses of the arc-complex aggression territoriality coexist with the vast potential for consciousness, reason, empathy, and creativity residing in the cerebral cortex.
This capacity for change, for self-awareness, for consciously choosing our path forward seems absolutely essential when we consider the dangers we face, particularly from technologies like nuclear weapons that put the very survival of our species at risk.
But the source material, importantly, doesn't end on a note of pure despair. It points to genuine global shifts, however imperfect, towards survival, equality, and compassion, and it consistently frames science as the indispensable tool for understanding our challenges and hopefully finding solutions.
Yeah, and the sources leave us with this powerful, lingering thought. Carl Sagan reflects that if that Ionian spirit of free inquiry, of experiment and observation had won out earlier in human history, perhaps humanity would already be exploring the stars.
He also emphasizes the immense dangers posed by our current technology and the stark possibility that our long-term survival really hinges on us overcoming the contradictions posed by the vagaries of past brain evolution. Will we ultimately be undone by those ancient parts of our own minds?
Will humanity choose the path of courageous exploration and understanding, guided by reason and compassion? Or will the legacy of suppression, of fear, and the ancient aggressive impulses within us lead to self-destruction?
The source material, through Sagan's eloquent words, makes it crystal clear that this choice is fundamentally ours to make. It's really up to us, the inhabitants of this small planet, to make our world significant by the courage of our questions and by the depth of our answers.